Okay, welcome everyone. Thanks for coming. Let me tell you the plan today. So this is our first regular webinar. This is not an orientation. This is a webinar on statistics where we're actually going to do statistics and talk about them and understand them and use them. So and all my webinars will start with Q&A. If you have any questions, pop in the chat box, ask me whatever it is, and I will do my best to answer your questions. And I want to let you know that I always start with Q&A and also end it with Q&A. But if you have any questions in between, pop those in the chat box too or ask. And I'm always happy to, answer. That's kind of the whole point of the webinars is that way you can get your questions answered immediately. Whereas the chapter videos, they teach the same stuff, but if you have a question on those, you have to post it in the Q&A, and some hours later, I'll get back to you. But here we can actually have a conversation. So I want to remind you that this is the best time to ask questions where you want to get an immediate answer to. Then after Q&A, we will talk about sampling techniques. Turns out in the real world, that's actually one of the most difficult parts of all statistics. It won't be the most difficult parts for this class because you're not doing a lot of that because mostly you're just going to be answering questions on a computer and that's it. But if you actually have to conduct a study and, do the statistics, conducting the study could be really difficult. If you have to survey 1,000 people, that could take a long time. And you have to be able to do it in a good way so that you have really reliable outcomes. So we'll talk about different sampling techniques and the pros and cons of each. Then I know this is the name of the class, statistics, but we're going to look at statistics as the definition of what a statistic is. So some statistics you already all probably know, things like the average. That is actually a statistic. If you take a sample and you look at the average, which we call the mean in this class, that's the statistics. You also know the maximum or the minimum. I'm sure you know what those are too. But then we're going to have other statistics. The biggie is going to be the standard deviation. And that's a statistic that's really important. So statistics are going to be numbers that come from the data. We'll also look at charts. And charts you've seen too. You may not have looked at details of charts, things like pie charts and histograms and bar charts and stuff like that. But that's also an important way of displaying data because charts are very visual, great for presentations. People understand them, at least some of them. But we'll look at charts. Then we'll look at something called the Z-score. And that's a special statistic that helps you understand how unusual something is when you really have no idea about it. So Z-scores are great for that. We'll also look at variables. And that there's different types of variables, and we'll talk about that. It has to do with the survey question. And that's the goal of the day. And again, typically, webinars go between around an hour and 25 minutes, an hour and 45 minutes, somewhere like that. I can't know exactly how long it'll take. It depends how many questions you have and any other details. But that's just what we can expect. So are there any questions about anything about the class or anything else? This is a great time. You don't have to feel uncomfortable about it. That's the whole point of the webinars is to be able to, do a lot of Q&A time. Any questions? Okay, if you come up with questions as we go, please pop them in the chat box, and I'll be always happy to answer your questions. So make sure that you're not afraid to ask the question because it's like the whole point. So you'll make me happy if you ask questions. Let's call it that way. All right, if there's no questions, I will have one eye on the chat box the whole time. I'll try to, and the other eye will be on the screen that's got the stuff we're doing today. I wanted to start with an example. And this comes right from Gallup poll. You guys heard of Gallup poll? That's one of the major polling, that a lot of news stations use it to understand stuff. One reason I like Gallup poll is that it actually shows you details of how they did stuff. So I like it because then I can look into, well, did they do their stats right? Whereas, just general news stations often don't say anything. They just give a headline and that's about it. Gallup poll does more. And this is actually article I looked at today. And the beginning of it says the following. It says the vast majority of US workers wear casual clothes on the job most days. Okay. By the way, I'm wearing a t-shirt, but there it is. So I'm wearing casual clothes. So I'm one of them. Okay. With more than 7 in 10 saying their typical workplace attire is business casual. I think I'm even more casual than business casual. Okay. 41%. Or more dressed down. Okay. Casual street clothes, 31%. Another 23% of workers say that they wear a uniform at work most days. And just 3% say they're wearing business professional clothes as their norm. Okay. So it's kind of a new society. When I was a kid, everyone wore like fancy business crap. You had to wear a tie to work. It was horrible. At least I think it was horrible. Nowadays, you can wear casual clothes. So they did a study, and that's what they found. So a couple things. Did they know that the vast majority of US workers wear casual clothes on the job most days? Did they ask everyone in the United States? Right? How do I know they didn't ask everyone in the United States? I know for sure. And I bet you know for sure too. Yeah, so how do I know? I don't see y'all jumping in. They didn't ask me. And I'm in the United States, by the way. Lake Tahoe Community College is definitely, Lake Tahoe is in the US. So they didn't ask me. Did any of you get asked? I've been teaching for like 30 years and I've never had a student say yes to one of these surveys yeah, I was one of them. So do they really know about all US workers? They can't. Okay, it's not possible. Okay, you can't ask them all. Okay, it just isn't even possible to do. Okay, no one has that kind of time. By the time you're finished, there's another 100 million people that have been born because it would take decades and decades to ask everyone. It can't be done. So what you have to do is you have to conduct a survey. And you use that survey to make an estimate or a guess, but an educated guess on what the whole population has. And Gallup is actually a pretty reliable organization. Okay, it's not perfect, but it's actually pretty well done. And at the bottom, unlike a lot of websites, they actually tell you how they did the survey. And what it says is results for this Gallup poll are based on telephone interviews conducted August 1st through the 23rd with a random sample of 396 adults aged 18 and older. Okay, did I mention it last time? You never want to ask people that are children all kinds of legal issues. Okay, unless you absolutely have to, but avoid children in any survey you do. And that'll be your projects, by the way. Do not ask children in your projects. Okay, just let you know that. So living in all 50 US states in the District of Columbia who are employed but not self-employed. So that's who they asked. For results based on a total sample of national adults, the margin of sampling error is plus or minus 6% points at a 95% confidence interval, at confidence level. I'll let you know that last bit, that you're not supposed to understand at all. But in about 3 weeks or so, we're going to spend a lot of time, like a whole week, just on that. So I'll let you know that that's coming. Just it's not here yet, but that'll be a biggie, understanding what that means. So right now, it's pretty complex. All reported margins of sampling error include completed design effects for weighting. We'll look at the weighting in a bit. So each sample of national adults includes a minimum quota of 80% cell phone recipients or respondents, 20% landline respondents, with additional minimum quotas by time zone within region. Landline and cellular telephones are selected using random digit dial methods. Okay. In addition to the sampling error, question wording or practical difficulties in conducting surveys can introduce error or bias in the findings of public opinion polls. So I like to bring in a real one. Okay, this is a pretty new poll. It was done last month, and this is how it's really done. So I want to look at kind of the pros and cons, what they did right, what they could have done better with a lot more work though, and the kind of the ways they did it. Okay, so the first thing is they tell us that they surveyed 396 adults. Is that a lot? What do you think? Yeah, it turns out that's actually not a very big sample size. That's actually smaller than they usually use. I looked at that, really? Usually you want just a little over 1,000 to be nice and reliable. So theirs is a bit too low. So I'm going to criticize. I'm not the one that did the survey, which means I can criticize without feeling bad about myself, at least. So they could have done a little bit better because 396 is a little bit low. And I say 1,000 is good. I want to let you know, there's 300 and some 41 million people in the country. You're never going to get them all. And 1,000 is a tiny proportion of 341 million people. But it turns out 1,000 is still good. 396 is still a little bit small. So I'll let you know, and we'll learn about that later in a few weeks on how do you decide how big you want your sample to be for reliability. Okay. So that's one thing. Here's something I do not believe they did. I do not believe that, where did it say? And that's the random sample. They didn't truly do a random sample. So random sample, what that really means is that every single adult in America that, qualifies, so they have to be employed but not self-employed, every single adult that qualifies has the exact same probability of answering as any other adult. Does that make sense? That's what random means. Okay, and I could tell you that's not true in this case, and they do give a little issue here. They don't get in the details, but difficulty in conducting surveys. Kind of do it very vaguely. All right, so here's the thing. I'm going to ask you a question. I want you to post in the chat box, yes or no. Have you ever received a call or a request to answer a survey and declined to answer? Okay, this is what I expected. So far, everyone I see said yes. And by the way, I'm a yes also. So here's an issue. Right away, there's bias. And the bias is the fact that people are declining to answer. Does that make sense? So we call that voluntary response bias because they can't force you to answer. You voluntarily answer. And there's a certain type of person that tends to answer. Okay. I'm not a sociologist. I did minor in it, but that's not my profession. So I can't tell you exactly what type is a type to not answer a phone. You got to ask the sociology people that. And, but I will tell you that, they're not the same as everyone else. Okay. Maybe they're busier, so they don't answer. Maybe they are a little bit more stressed about things because they don't want to give out their information. That's possible. I'm not sure. Those are just guesses. But the point is, the type of person who doesn't answer might be a different type than who does answer. And that type might be more likely, for example, to wear formal wear when they go to work. Okay, I don't know for sure, but that's a possible bias. Any questions on that idea of what bias is? Okay, so bias means that you've asked only a certain type of person, and that type of person is more likely to answer one way than the other way. And that's what bias is all about. Okay. On the other hand, if it was like, let's say they only ask people of type O blood, my guess is there'd be no bias there, even though you're ignoring all the people in type A or B or AB. Because I don't think, my guess is blood type has nothing to do with what you wear to work. Maybe I'm wrong, but that's my guess. So that wouldn't be a bias, even though you're only selecting a certain kind of person. Okay, but when you have a voluntary response bias, there's almost always going to be some bias. Yeah, so the survey is considered slanted, is another way of saying it, one way or another, because of the bias. Okay, whereas if it's not slanted, it's not biased. Okay, so that's a big deal. Okay, what they also did is they said that they did it random, and what they really mean, because I guess I should have mentioned this. One of my very first jobs, I worked for a market research company, and I called people and I conducted surveys. Let's see if you put the chat cut. Any guess how old I was? Okay, you're not my generation. You don't realize how it used to be. I was 12. Things were different in those days. Children worked. Yeah, I was 12 and I did that, but I got to learn, and it had nothing to do with being a stats, but I was a 12-year-old kid. You know, I didn't really know anything about stats. But what I did, I learned, not because I wanted to be a stats professor or anything, but I learned how it really works because I've got hands-on experience. And you do randomly dial, and that's what you do. You can get randomly generated phone numbers, basically. Just pick random numbers and call that last 4 digits, and that's random. Does that make sense? The first 3 will tell you what area the person is, and the last 4 is just pretty random. So you randomly select those last 4, and then that's random. That's what they did. So that's actually pretty good. At least they did that. They still have the voluntary response bias, but at least they didn't have bias in other ways. Any questions on that? Okay. So anyhow, that's the kind of survey they did. Okay, they tried to do random, but you can't do voluntary. You can't handle because of the voluntary response bias. Do you know how to avoid voluntary response bias? What might you do? There is a way to do it. See anyone jumping in? Let's put it this way. If I were a surveyor, not your professor, but I was a surveyor, and I came up to you and said, I'm going to give you $500 if you spend 5 minutes with me and answer these questions for a survey I'm doing. Would you do it? I'm going to give you $500. I got my money. You see my cash. Okay. I would absolutely do it. And I have actually, they've done that to me. They only gave me $100, but I took it. So yeah. So that's one way of doing it, is you give them money. And that's one way of handling the voluntary response biases. You give them money. Okay. There are other ways too, and I'll talk about that in a bit when we get into cluster sampling. All right. So now I wanted to give you like a very solid example. And this is a solid example. I literally looked in today's news and was able to do it, which is great. I'm always able to find something in the news. So let me talk about some of the vocabulary for surveying. Okay. First thing is we want to talk about the types of variables. Okay. So the survey question in this, okay, the survey question is, what kind of attire do you wear? Do you wear business casual? Do you dress down? Do you wear casual street clothes? Okay. Or do you wear a uniform? That was a survey question here. The answer to that wouldn't be 28. It would be a word like business casual. Okay. If it is a word, then we call that variable qualitative. So this is an important definition. A qualitative variable is a variable that comes from a survey question where the answer to the survey question is a word. Okay. And there's a special kind of that, which I didn't write in here because it's kind of obvious. When I say it, you'll agree it's obvious. It's called the yes-no question. What do you think the answer could be? Be obvious. What could the answer be of a yes-no question? Nothing fancy here. Yeah, yes or no. Does that make sense? So a special type of qualitative is a yes-no question. Okay, and we're going to spend a lot of time on the yes-no questions. They come up often, by the way, in lots of surveys. Okay, we will spend a chapter on the qualitative that aren't yes-no, but we spend multiple chapters on the yes-no. Kind of the opposite of qualitative is quantitative. So that is a number answer. In terms of being able to do statistics, which is math, by the way, what do you think is better, qualitative or quantitative? If you want to be able to do math on it, this should be obvious. Yeah, quantitative is better because those are numbers, and math works much better with numbers than words. Does that make sense? You could add numbers together. You can't add words, right? Yes plus no doesn't mean anything, but 7 plus 2 does mean something. So if you have a choice, you should do quantitative. So for example, if you're thinking, well, I really want to find out, people like their job. So instead of the survey question, do you like your job? How would you turn that into a quantitative survey question? What might be the question you would ask instead of do you like your job? And you've seen these all, not in this class because we haven't had this class yet, but you've seen it in life. Yeah, use a number scale. So maybe on a scale from 1 to 100, with 1 meaning I absolutely hate my job, 100 meaning, boy, do I love it extraordinarily amount. That would be 100. How much do you like your job? And then you have a quantitative survey question. So there are some surveys that you can turn into quantitative. There's others that you can't. So for example, what is your ethnicity? Good luck making that quantitative because there's no numbers to Latino or Caucasian or, African American. That doesn't work with you can't. There's no numbers to that. So there are some that you have to do qualitative. Okay, but some that you can turn into quantitative, and if you can, go for it. Any questions on the main types there? Okay, it turns out with quantitative, there's 2 types. There's discrete, which means you can list all the possible answers. And then there is continuous, which means you can't list them. So discrete might be, how many pets do you own? Right, a person can own 0, 1, 2, 3, 4, 5, maybe up to 100 if they're like a super pet person. Okay, and that's it. You could list all those possibilities. Do you see that? It might, whereas continuous would be something exactly how much do you weigh? Right? I weigh 168.235716 ... pounds. Okay, if it's the exact amount, then that's continuous. You couldn't list every weight that could ever happen. Okay, with unlimited decimals, for example. So that would be continuous. Just let you know that discrete can have some fractions. For example, see if you can put in the chat box. How many siblings, including yourself, are in your family? Okay, the reason I ask this, no one ever says what I said. What no one ever says what I am. For me, it's 4.5. How does that happen in the modern family? I have Laura, she's a step sibling or a half sibling. So that can happen, but you can't have 4 1/3. That's not possible. So you still can list all the possibilities because you can either have whole numbers or halves, and that's it. So that would be discrete. Any questions on kind of the difference in these different variables? Okay, sample size, by the way, in this example, they told you that they sampled 396 adults. So the letter we always use in statistics for sample size is lowercase n. So lowercase n is the sample size. And you say n is 396. It's not supposed to be hard or anything, but get used to it. We're going to see it a lot, n, because sample size is very important in statistics. Okay, so now let me go through, and again, feel free to ask questions if there are any. I don't think I've done anything too hard yet, but that will happen, you know. Now we're going to go through all the different types of ways of doing sampling. So one is convenience sampling. And I want to let you know that's actually, if you want to do research and have very reliable information, this is the worst. And that is, you survey whatever's easiest. Hey, you want to do a survey of 30 people? Ask your friends. That's convenience sampling. Okay, but that's horribly biased. Okay, there's voluntary response bias. There's all kinds of other bias involved with convenience sampling. People, and this is psychology more than statistics, but people tend to ask people like themselves more often than people not like themselves. And psychologists have like determined that. So there's all kinds of bias in convenience sampling. So again, convenience, you just do whatever's easy. Sound good? Okay. And by the way, not all sampling has to be people. For example, if you wanted to find out, you know, what the average height of pine trees are in Sierra Nevada forest, right? You don't ask people, then you measure trees. There's no voluntary response bias. A tree will never say, "Don't measure me." They're a tree. But it's very, you could never measure every tree, not if you know anything about the Sierra Nevada forest. There are millions and millions, maybe billions, I'm not sure, of like so many trees. But you could measure trees and you could do convenient. I can just go in my front backyard and my little neighborhood and I get hundreds of trees just from that. Just from like with a 3-minute walk, I can get 1,000 trees. If you haven't been to Tahoe, then trust me, that's how we are. We have a lot of pine trees in Tahoe. And so if I just do my little street and measure all the trees, that would be convenience sampling. And it would be severely biased because my little neighborhood is not the same as everywhere else in the Sierra Nevada forest. Because there's areas of Sierra Nevada forest that has only small trees if it's really high elevation, for example. Okay. There's areas where they have really, really tall trees, especially if they were never cut, like in Tahoe. So there's all kinds of issues with convenience sampling. Okay. So never use convenience sampling when you care about the results. Okay. And you want reliable information. Okay. So let me give you some more. Okay. So first thing, one more thing about this, because I think it's an important definition. In terms of the numbers you get from sampling, you're either going to get a statistic or a parameter. A statistic comes from the sample. Parameter comes from the population. Okay. So often you'll call that a census. And that's actually in our Constitution, what a census is. It means you ask everyone, which is very difficult, by the way. Sometimes you can do a census. For example, I could, but at the end of this class, I can easily do a census on grades in the class. because I just go and look at the grades for all the students and I have my census. The population isn't very big, so I can do it. Whenever you have a very big population, like all of America or something like that, you just can't do the census. Okay, it's just not really reasonable to even try. So instead, you do a sample, and then numbers you get from the sample, things like the average, which we'll call the mean, those are statistics. That makes sense to everyone? Okay. All right, so this one, random sampling, we already talked about. That means that every individual is just as likely as every other individual to be selected. Okay, and to answer the survey question. Okay, often, usually impossible. If you want to do a random sample of Americans, and with a sample size 1,000, can you do that? Let's say you had, $20,000 to, do your study. Could you do that? You wanted to randomly sample 1,000 Americans? Okay, the answer is no. Because there's no way to truly randomly sample. The only way to randomly sample really is to get a list of every American, use a computer to randomly select those 1,000 Americans, and then go to those 1,000 Americans and then survey them. Okay, first thing, it's against the law to get a list of every American. There may be lists out there. It is against the law to do that. You'd have to hack into the police computer systems for every area or something like that. Okay, even then you couldn't, because there's homeless people they don't even know about, or other people. You just can't do it. Okay, it's impossible. Okay, random sampling, if you can do it, it is the best. But if you can't, then you have to try something else. Any questions on that idea? So if you can get the list of the population, then it's doable. But if you can't, it's not doable. Any questions on that? So I could randomly sample 5 students in this class. I could do that. Okay, and you could too, because you could get a list. You actually have access via Canvas to all the students in our class. And you can survey 5 students. Give them a lot of money so that they answer that survey. Do you see that? So if the population size is not that big, random samples is possible. Big population size, forget it. Okay, so it's doable it's not smaller subsets, it's smaller populations, really is the issue. Any questions on that? Questions? All right, so there's a special kind of random sampling, and that's simple random sampling. Okay, and simple random sampling means you order the entire population, use a computer to pick n random numbers from 1 to the sample size, capital N. We typically use capital N for the population size. Let's just say population size. And then survey the selected individuals. Okay, with the large population, you can't do that because you can't get a list of them all. Okay, so that one's not usually done because it's too hard. So then this is the one that's done most often in research, and that's called stratified sampling. So the idea is you think about what bias might there be amongst those in the population. So for example, in our example here, we're looking at the kind of clothes the workers are wearing. So one of the biases you might think about might be age, right? 18 and 19-year-olds might tend to dress differently, not want to be so formal, I don't know, than maybe 40-year-olds and 50-year-olds. Does that make sense? So you may think it might be a bias in age. So you say, well, let's let age be our strata. So step one is decide on the strata. Age is an example of strata. What other strata might you see besides age for people at least? Yeah, gender could definitely be strata. Okay, what are some? Income, definitely. And maybe type of job. That could make a big difference. How about ethnicity or race? Those are typical strata people use. Does that make sense? So step one is decide on the strata. In our class, because this is elementary statistics, we're just going to do one. In the real world, you do multiple strata. So you can get rid of a whole lot of biases, but we only have so much time in our class. Okay, so we're just gonna focus on like how do you do it with one. Okay, step two. You research the percent of each of the types. Used to be very hard. Now it's very easy because of the internet. So if you wanted to do a strata on age, you just go online and in Google will tell you in less than a second if you type it in, how many people of each age bracket are there in America or something. You see? And Google will tell you the percentage of each group, of age, or each, what percent are male, what percent are female, what percent are other. Okay, what percent are Caucasian, what percent are Hispanic, what percent are African American, etc., Asian, etc. So you could very quickly research the percent of each type. Any questions on that idea? Okay, step three. Step three is you multiply the percents, as decimals, by the way, by the sample size to establish quotas. So let's say you're going to do a sample of size 500. That was your goal, right? And let's say you want to, do it by age, and let's say you find out 20% of adults are between 18 and 30 years old. Okay, I have no idea, so don't quote me on that percent. But let's say that's what you found out by asking Google. Okay, well then you do 20% of your 500 is 100. So your quota for age 18 to 30 would be 100 of them. Okay, that's the multiply. Because if you take 0.2, that's 20%, times 500, that gives you 100. And in this class, you'll always let us use a calculator. Just because I have they sometimes call me the human calculator. I have these weird abilities. So just because I do it in my head, I do not expect you to do it in your head, but I do expect you to know how to use the calculator. Okay, that is important. Okay, so you multiply the percents and you establish quotas. And then the last step is you conduct the survey ensuring the given quotas. So then you make sure that you ask exactly 100 people from 18 years old to 30, if that was your quota. Okay, and you do that make sure that in each of your age groups, you have exactly the number in your quota that you have surveyed. Okay, any questions on that idea? Okay, I want to remind you, it's not necessarily just people. It could be, like I said, pine trees in the Sierra Nevada forest. And you might say, well, one of the main strata on that might be elevation. Right? In the Sierra Nevadas, there's, between 0 and 1,000 feet, between 1,000 and 2,000, maybe you do it by 1,000 feet. And then you look to see, and you can, maybe go to the Forest Service and find out what percentage of the trees are, between 0 and 1,000, 1,000, 2,000 in the Sierras. And then you make sure that when you measure trees, you measure the right number for each of those groups. Okay, so again, it's not always people. A lot of times I'll, don't get confused if, you think all my examples are people, so must be people, but sometimes surveys are about something else. Could be dogs or trees, or, it could be whatever you're making in your manufacturing plant, whatever you're doing. Any questions on stratified sampling? That is, I would say, the most commonly used sampling technique in any kind of research. So I did want to spend a lot of time on that. Any questions on stratified? All right. Then there is cluster sampling. Okay, that's probably the next most common. And that has steps. That is, you divide the population into clusters that represent the population and then sample every item in each cluster. So let me give you the pine tree example, because that's an easy one to talk about. Is the clusters you might choose might be acres. Very easy to go on Google Maps and, get a map of the Sierra Nevada forest and have it, cut up by acres. Does that make sense?
I thought we were Buddhists. I don't know, Dennis. You sound a little sus.
Sound a little what? You have a question or maybe
Oh,
not?
sorry, my bad.
Okay. Yeah, because I was just talking about pine trees. I don't think that has to do with religion, does it? Yeah. So anyway, you look at the acres in the Sierra Nevada forest, and then what you do is you find some acres that represent the Sierra Nevada forest. So you're going to do maybe a couple of them that are at the high elevation, maybe over 12,000 feet. You're going to do some at the low elevation, kind of nice proportion amount, and maybe pick 10 acres or so total. And then you go to each of those acres, and then you measure all the trees in those acres that you have chosen. And that'll get you a nice sample of the trees in Sierra Nevada. Okay. And again, if you only did 5 acres, it sounds like a lot of work, but there are a lot of acres in the Sierra Nevada forest, like maybe hundreds of thousands. I'm not sure the numbers, but a lot of acres. So you're going to pick some that represent the population. For students, let's say you wanted to survey students at your college. Okay, it might be Lake Tahoe Community College. What do you think the most common clusters would be? It's very clear. If you don't know, I'll say, and you say, of course. Very clear clusters. Not major, it turns out. The problem with major is there's just too many in each major. There aren't that many majors at our college. Age, that would be too difficult to survey everyone who's, say, 19 years old. Good luck. Academic year, no. All right, let me tell you. Classes. So you're in the Math 201 class, right? Of this section. And what you do is you just go to the scheduled classes and you pick some representative classes, maybe a statistics class, maybe an English class, maybe an art class, maybe a, forest service class in our college, kind of classes that represent. And then you go over to the classes, you hand out a survey with a piece of paper to every student in the class. Okay, and we're a small college, so that's like 15 students, maybe 30 in each class. So you don't have to, you have to, you'll get it. And that's not very hard. Do you see that? And that's done pretty much whenever you're doing, almost all college surveys are done that way. They do cluster sampling and they do it by classes. Most, not all, but most are done that way. Okay, so cluster sampling, the big thing about cluster sampling is 2 main good things about it. One is it is logistically a lot easier because you don't have to travel that much. You can just go into a class and ask all 30 students or whatever, and then go to maybe 3 or more classes. You can't just go to one, by that wouldn't be cluster sampling. That's convenience. You'd have to go to maybe 5 classes. And so that's pretty convenient. It's pretty easy. The other big advantage is there's no voluntary response bias if you do classes. If I asked you to, answer my survey, you're all going to do it because I'm telling you. especially when the professor asks. That's the good news, is that the students will answer the survey. So there's very little volunteer response bias. That's not a big issue. Okay, so that's the good news. Okay, sometimes clusters are kind of hard to find and stuff, but not for college students, for example. Okay, I want to give you a heads up that for project 1, you are going to have to conduct a study, and you're going to have to either use basically stratified sampling or cluster sampling. So make sure you understand what these are, and you're going to have to follow the steps I just went through. Any questions on stratified and cluster sampling? All right, there are other sampling. There's what's called systematic sampling. That is done especially in manufacturing. And that is you sample every nth item in the population. So let me give you an example that I did. It was a while back, but it was a former student of mine who ended up graduating and went to business, and he had a company that manufactured hotel towels. So he made towels for hotels. And he wanted to show his towels were better than the ones made in China. So he actually asked me, what's a good way of sampling towels? And what he was going to do is he's going to use them a whole bunch of times and see, how long it takes for them to deteriorate. So what I told him was systematic sampling. And what he did is I think it was like every 200 towel that came off the assembly line, he grabbed that towel and tested it out. And he put it in the wash a bunch of times and, did his stuff and see how long it lasted. Okay. And he did it for the same ones that he was able to get that was made in China. And he sampled those towels using systematic sampling. Okay. So one thing is systematic sampling only works when it's an ordered group. If it's not an ordered group, you can't really systematic sample. If you can't order, forget it. So the population of the United States would be pretty hard to systematically sample because we're not really ordered. You could do it by birth, but we don't know everyone's birthday, for example. Okay, so, but manufacturing works really well. Convenience sampling, I already talked about, whatever's easy. The last one that's really important, any of you in health sciences? I think I saw on the discussion post that there were a couple in health sciences, like want to be a nurse or a doctor, or whatever in medicine. It's a yes or no. Are you in it? Or your goal is that? This is a biggie in health science. I don't see you popping in. It should be yes or no. Easy type. Maybe you're interested in health sciences. Well, maybe not so many, but it's still important. But let me tell you, give an example that was a really important example a couple of years ago. The most important study that was done a few years ago. What was the most important study that was done a couple of years ago? At least I think, and I think you'll agree that was most important, but. We got a nursing major. Good. Okay, what was the most important study that was done? Statistical study. You don't know? Yeah, good. I figured, the first person would say exactly what I think too. Yeah, COVID vaccine. Okay. So COVID vaccine test, and that's important too. I wanted to go over the COVID vaccine itself. So does the COVID vaccine work? And if you're, working for the FDA, testing Pfizer's vaccine or Moderna's or J&J, you want to make sure that it's not killing people. It's not going to kill 20% of the people who get a vaccine. That'd be horrible. Okay. And that it actually stops COVID. Okay. It's not going to stop it 100% of the time, but you want people to be less likely to get COVID if they've gotten the vaccine than if they haven't. So here's what they did. Okay. And this really is what they did. One thing is that I made sure I read about it because I wanted to make sure I knew that they did the right thing before I got the vaccine. And what they did is they got a sample of volunteers. How many people do you think were in the sample? Any guess? Some of you might know. In the first one that was done, which was Pfizer, actually. 1,000. Any other guesses? Right, 40,000. Okay, they got 40,000 volunteers. Now, there's no way you can get 40,000 volunteers using a random sample. Okay, or even volunteers are really hard to do any randomness in. But here's what they did. They took those 40,000 people and they split them into two groups, what they call the control group and the treatment group and the placebo group, often called the control group. Okay. And once you get your volunteers, you can put those volunteers in a computer real easily and have the computer pick. I'm not sure if they really picked half of them, but I'll just say that. I'm not sure what percent were control and what percent were treatment. But they put in two groups. Let's say they put in into a group of 20,000 and another group of 20,000. And then they had the computer randomly select 20,000 people. Computers do a really good job of randomly select, by the way. That's one that you can trust me on. You can attend my office hour and I'll torture you with how it's done. But it's a lot of math and computer programming. So just trust me that the computers do it right. So they randomly selected 20,000 using the computer. And then what they did is they made 20,000 shots with placebo and 20,000 shots with the vaccination. They didn't tell the doctor or nurse and they didn't tell the patient. So the doctor and nurse just wrote down the serial number, had no idea. The patient had no idea either. And then I think it was something like 6 months later, they found out which ones got COVID and which ones didn't get COVID. Okay, that is called a randomized control study. And it is very accurate because there's no bias. Because if you don't know which side you're on, you're not biased one way or the other because you don't know. And even the doctor doesn't know, so they can't even give hints. Any questions on that? Okay, and by the way, and we'll talk about this later, it was very clear that the vaccine worked. That your chance of getting COVID after you get vaccinated was much smaller than the chance of getting COVID had you not been vaccinated. Okay, even though you didn't even know if you were a treatment or if you were a treatment group or control group. Any questions on randomized control studies? Okay, so that's especially done in medicine, but it's done in other places too, but especially medicine. Okay, so let's get in. That was basically chapter 1. Just want to let you know. And I don't have time to do every little detail because you'd be tortured with 6 hours of lecture. So you should read the book and watch the other videos too to make sure that you get the rest of the details too. But I give you the main topics. And that's what I'll do in every webinar. So let's move into chapter 2. And that is really about statistics. And let me go through and talk about important statistics. It's not really number 7, so I don't know where that came from. Okay, so first thing, the definition of a statistic, very important. It's a number that is calculated from the sample data. Okay, so you have the sample, you have the data that comes from a sample, and you calculate a number. All right, if it is the yes/no question or any qualitative question, that number is almost always proportions. There's not much else there is. What percentage of people said yes? That's it. Does that make sense? So I didn't write that down because that I think you probably all knew before you even jumped into this class. But if it is quantitative, then there are many, many different statistics you can look at that help you understand the data. And I'll give you the one that you all know first. You may not know the word, but you know another word for it, and that is mean. By the way, that doesn't mean, someone's being mean to you. Nothing to do with that. It means average. And I think you probably learned in, I don't know, fourth grade or something, it means add them up and divide by however many you had. You've all had the word average before, and maybe you've known the word mean also. So in our class, we'll call it the mean and not the average. Any questions on that? Okay, there is the median. You've heard the median also. Anyone remember what the median is? In one word? That's like an easier word that people understand. Also starts with an M. That's a hint. Yeah, middle. The middle. Okay. And it turns out it's a little more complicated. It's the middle or the average of the two middles. So if there's, if there's an even number, like 20 people surveyed, it would be the average of the two in the middle, because that could happen. Okay. And that is the median. Okay. Then there is a standard deviation. Do you notice something about my font here? The way I wrote this? What did you notice with this word standard deviation? It's not an accident. Yeah, it's bold and large. Okay, there's a reason for that. It is important. Okay, of all the statistics, this is the biggie. Okay, mean is important too, but since everyone knows what the average is, I didn't need to bold it. But the standard deviation is a major, major statistic. And what the standard deviation tells you about is how spread out the data is. And I'll go over some examples in a little bit, but it gives you a number that tells you how spread out it is. And we'll have lots of examples in a bit. But first, I just want to kind of go over the general ideas first. I'm going to say the formula really fast. By the way, pop in the chat box, yes or no. Yes, you have had a lot of math, like at least calculus. No, you haven't. Okay, that's kind of what's expected. Everyone said no. So I want to let you know you are not responsible for knowing all the math. If I say it really fast, that means you're not responsible for it. Sound good? So the standard deviation is the square root of 1 over n minus 1 times the summation from n equals 1 to n of x minus mu quantity squared. So you don't need that. Just let you know that. Or if you know calculus, there's it's the integral instead of the sum. I'm not even going to go there. So you don't need to know it. But what you do need to know is the idea of the standard deviation. That's really important, not the formula. And also how to see it on a calculator, which will be easy. Trust me on that one. We'll see that in a bit. Okay, there's Q1. That is the first quartile. And that really means approximately 25% are below that number. So kind of below that is a lower 1/4. Then there's a third quartile, and that means 75% is below that number, approximately. And that is basically, it means that above that is 1/4. Okay, and that's the third quartile. I do want to give you a heads up. This is of all of mathematics and statistics, this is the thing that drives me the most crazy of anything. And that is, and maybe you'll understand, but being a mathematician, none of you are mathematicians, but there is no agreed upon formula for these things for the first and third quartile. Isn't that terrible? If you use Excel, you'll get a different answer than if you use the, say, TI-84 calculator. It'll be slightly different. So then what you're going to be responsible for are the ideas, not the numbers exactly. Okay. You can put the number in, but really I care, the ideas are much more important. because it's just stupid that there isn't a formula that everyone agrees. There's like 3 different formulas people use. Isn't that terrible? So sorry about that. Don't shoot the messenger. I've actually written to the National Statistics Association and they didn't even respond. Okay, then there's the z-score, and here's a formula, and that is z is there's going to be some letters here that are important. X is going to be so it's going to be x minus mu over sigma. X is going to be the given value. So you might find the z-score for 12. This letter here, this is a Greek letter. And I know someone in the webinar yesterday had a cat. So I always like to remember what does a cat sound like? Mew, mew. And that's how you read this. So think about a little cat and there's a little tail on the bottom. Do you see that? Okay, just one way of looking at it. And that we call that mu. And that's a Greek letter. Anyone speak Greek in this class? Yes or no? I speak Greek. You're fluent in Greek? You speak Greek? Because we're going to do a lot of Greek in this class. Yes, no? Yeah, I've actually never had a student that spoke Greek fluently in my class. So thought maybe today, but I don't think so. So you're not responsible for speaking Greek, but you are responsible for knowing a few of the letters. And this is one of them. And this is mu. And it's the mean. And this guy is also a Greek letter. And this is sigma. And that's the standard deviation. Okay. When you use Greek, you're talking about the population, it turns out. I'll talk about that another time. All the different lettering. Any questions so far about any of the general ideas on these? All right, so what I want to know, I want you to put in the chat box. First person to put it in is going to get your question answered. What quantitative information are you interested in about each other? We're going to do a survey. So what might be a survey question that you'd be interested in each other that is quantitative, so number answer. Pop in the chat box. First one who pops it in gets their answer. Okay, number of animals you live with. Okay, so the number of animals you live with is the question. And by the way, let's not get into tactical biology on this one. So, like if you have a bunch of ants in your house, we're not going to count that. Sound good? So these are animals that you want in your house. We're not going to count flies that happen to be like, gnats and stuff that might go into your house. So that could be dogs or cats. And I think my guess is, and my guess is you want animals and not animals, just a guess. And you're not going to do the biology thing and say people are animals, is my guess too. So that could be goldfish could be animals, by the way. All right. So what we're going to do, and I'm going to go now to the calculator. We're going to go to the one variable statistics calculator. And I want you to put in the chat box the answer to the survey question. How many animals do you live with? And I'm going to pop them in and separate by commas. 5, comma. Got lots of. So 5 to 13, 0. Then 0 to 1, 2. 0, 1. Okay. So when you put in the calculator, I tried to make it easy. Hopefully that didn't look too hard with it. Typing it in. Make sure you separate by comma. Just a note for this calculator, if you have a number like 20,000, don't go 20,000. Don't put commas in numbers. Got it? Because then it'll read it as 20 and 0. So just a note for this is make sure you don't use commas in large numbers. So you separate each number by comma. Okay. Let's say this is a sample of online statistics students. So now it's a sample. So I'm going to click on sample standard deviation. Now you hit calculate. Was that hard, by the way? Did it look hard to put that in the calculator? I tried to make it easy. Okay, so the mean is 2.7. Okay, so that's our statistic that gives you the sample mean, okay, often called the average number of animals that people live with, that students live with. The minimum was 0, so that's the smallest number of animals. Q1 is also 0, so notice that at or below 0, 25% were at or below 0. Do you see that? At least 25%. So that's why Q1 happens to be the minimum. It won't always be true, but if the minimum and Q1 are the same, then you have 25% at least at that exact bottom number. Any questions on the Q1? Okay, the median is 1.5. So if we ordered all of you from smallest to largest in number of animals you live with, then 1.5 would be right in the middle. Q3 is 3. So that means about 75% are kind of fewer than 3 pets. That's fewer than 3 animals living with. The maximum was 13. And again, I'm going quickly on these because these are supposed to be not that hard to understand. Do you agree they're not too bad? Okay, standard deviation. Let's round it to about 4. Okay, notice that's a pretty big standard deviation. Okay, so what that means is that it's like an average amount it's spread out by. So the average or the mean was 2.7. And if you go left and right by about 4 or 3.9, then that's going to cover the majority of the data, but not all of it. Any questions on that idea? Okay, the variance, which I really don't talk about in this class. Some other classes at other colleges use it a lot, but I don't. It's not very useful. So don't do much with it in your project. Don't do any more than the variance is, and you give the number and just move on. That's not going to be important. The IQR, that's 3. And that is if you take basically Q3 minus Q1 is the IQR. And that's the interquartile range. That's what IQR stands for. And what it means is the middle 50%. So the middle 50% has a range of 3. And it's between 0 and 3 in this case. Any questions on that? Any questions? The sample size was 10. That means that 10 of you answered the survey question. Any questions at all on any of these statistics? Okay, I'm going to show you another thing we can do. Actually, I think I don't even want it this one. I'm going to show it to you this way. It's a little early, but it's good to practice. So I go to project 1. And I go to project spreadsheet resources. And if I go to this first one, If I click on this guy, this is that spreadsheet, which I think I might have mentioned in the orientation at one point. So this is a spreadsheet, and I want to do it with the spreadsheet because it does some more stuff too. So let's put those numbers in. That was over here. That's 521300. Five, enter. 521300. 2, enter. 13, enter. 0, enter. 0, enter. 21301. Okay, so that is how you use a spreadsheet to calculate the statistics. And you'll notice it's still going to give you all the other things that we talked about, but it also gives you histogram. So here's a histogram. And so this is a chart that is used to understand and visualize the data. And notice that we have a big bar on the left, and then from there you have small bars to the right. Do you see that? So what we call that, when you have the big bar on the left and then small bars on the right, we call that unimodal and skewed right. Okay, so skewed right because from the big bar, you go to the right to find the small bars. So unimodal and skewed right. Any questions on that? Okay, if it was skewed left, then that would mean the big bar would be over here and then the small bars would be on the left. But this is definitely unimodal. And unimodal means one mode or one tallest bar. Okay. Any questions on reading that histogram and seeing that it's unimodal and skewed right? Okay, let me show you some more things that you can do. And when you if you go and use this for on your computer, it's going to give you all kinds of warnings about the possibility of getting attacked. I promise you, I have not written viruses to attack your computer. I would never do that. So that's one of those when it gives you the warnings, you say, okay, I trust it, do it anyway. I don't remember exactly what you have to say, but something like that. So it might do that. It might even completely block it, but hopefully not. And that's because, you know, computers are scared. If I go to stats and I go to box plot, this gives what's called a box plot. What a box plot is, sometimes they call it a 5-point summary. It shows the bottom here at 1 is, the bottom here at 0 is the minimum. Then we have the first quartile. I know what's happening. Okay, there's some more stuff that's happening with this box plot, and that is it's getting rid of the outliers. Okay, and if I go over here and hit no to that and start again, I want to do that and go to stats, box plot. There we go, that's better. Okay, it's a little messier. And you'll see the bottom is 0, that's the minimum. This here is the Q1, which is kind of pretty close to the bottom. And as I mentioned, there's no real exact way of finding it. So that's why Google, this is done by Google, by the way. I mean, I coded it, but I use Google's stuff. And their formula, Google's formula, is different than the formula I used on LibreText. Okay, and pain in the butt. But what you should understand is that around a quarter of it should be below 0.25. Okay, then the median was 1.5. That's right here. Then Q3 is around 2.75. And again, that's using Google's technique instead of LibreText technique. They're different. And then the maximum is 13. The box, which is what's in red, is the interquartile range between 0.25 and 2.75. So this is a way of showing those 5 numbers in a picture. I want to let you know one of the problems with using a box plot in presentations is that a lot of people don't even know how to read it. They look at this, have no idea what it is. And my guess is some of you might have been some of those people before today, right? Or maybe not. Maybe you all knew what box plots were. I don't know. But my guess is that some of you haven't really understood box plots before today or even seen them. But box plots are nice, and those who understand statistics know what a box plot is, and they're good for kind of showing what's going on. And one of the main, again, a main feature is this interquartile range, because it shows you where that middle group is. So if you say you're into business, you want to advertise, then this is the middle group that you're going to advertise to. Because if you want to advertise to your middle group, that's who you're going to advertise. Whereas this 13, this is the high group, right? Okay, so notice, by the way, if you were working, if you own some, say, pet store, you care about this high group because they're going to spend more money at your pet store probably because they have a lot of pets. Do you see that? Whereas these zeros, you're like, well, I don't need to advertise them because I don't have any pets anyway. They're not going to buy stuff at my store. Do you see how that works? So that's kind of how you use a box plot. Any questions on the box plot? Okay, there's another plot that won't work great with this one, but I'm going to show it to you anyway. And that is called the stem and leaf plot. And we have an outlier of 13. And this doesn't do much because if pretty much all of your numbers are single digit, there's no reason to do stem and leaf. So let me do another example where the stem and leaf is a lot more useful. So let's suppose instead of that, let's suppose we looked at the grade on the first exam. And I'm going to make some numbers up and pretend that they were true. Let's say the first person got a 98%. The second person got a 77%. The third person got an 82%. The next person got a 94%. The next person got a 55%. The next person got a 67%. The next got a 79%. And then an 87% and a 94%. And then an 81%, a 70%, a how about a 41%? And then how about 88% and an 87%, a 93%, an 86%, and a 91%. I'm just making some percents that could happen. These are like, say, grades, scores in the first exam. So now I can go to stats and I can go to stem and leaf. And what this does is it gives a picture of the data nicely, where what's All right, just had a disaster. You've probably seen these disasters before. Can you hear me? They're doing construction right there. They just took out our power. Sorry about that. Stuff happens. Let me go to where I was. There. I've never had that happen actually. I'm at work actually, never had it at work. I had it at home once, but never at work. Sorry about that. But yeah, so I'm here. And then you know how it is, you turn on your computer and then it says update in progress. Then I wait for that. It's pain in the butt. Okay, the good news is we got most of what we need to do today, and now we'll do another 10 minutes, we'll be done. Sound good? All right, so we were just talking about the stem and leaf plot. And there it is. So what this does is we get a histogram. Do you kind of see this histogram? This is also unimodal. There's one highest bar. Okay, and one of the nice things about the stem and leaf plot is that you actually can see all the data. Whereas if you just have a histogram, you don't know exact numbers. You only know ranges of numbers. But here we know, for example, there were 2 people that got between 87 on their exam. Do you see that? Because there's an 8, 7, 7. This 8 means the 80s, and there were 2 7s. So that means 87, 87 is how you read these. So you can actually see the shape of the distribution, and you can get back all of the original data in this picture. Okay. A few things is that this only works when you have, it doesn't work with single digit numbers, as we saw in the first example, because there aren't tens and ones, for example. So it doesn't work that way. The other thing is, if you're presenting this to an audience that hates numbers, they'll hate this because they're afraid of numbers. So you got to be careful. People who are afraid of math sometimes won't like this at all. The other thing is not everyone knows how to read this. So you can only present this to people who know how to read it. But for the educated people that don't hate numbers, this is actually a really nice way of displaying the data. And it's called a stem and leaf diagram. Any questions on that? Okay, so then, and by the way, this bottom part, I put in here in case you have visual problems. This reads out all the things that, that we can see. So in case you're blind, you can still understand the stem and leaf because I made that happen so that it would be accessible, they call it. But I want to show you a few more things that's in here. And that is, let's say we wanted to find the z-score for the 70%, because 70% means you just passed, barely passed. Then what I'm going to do is in the x, see where it says x value here? I'm going to type in 70 and hit enter. And it gives z-score, which again is the formula was x minus mu over sigma. But I programmed it so it actually gives it to you. And it's negative 0.7 about. Okay. If the z-score is 1, that means you're 1 standard deviation away from the data, from the mean. So we're within a standard deviation, which means that it's not very unusual. Do you see that? It's on the low side because it's negative. Negative means you're on the low side. Positive means you're on the high side. But it's not very low. Okay. On the other hand, what if instead you failed and got a 42%? So I put a 42 there. Now the z-score is negative 2.56 about. That means you're over 2.5 standard deviations below the mean. And that turns out to be very rare. So the z-score tells you how rare something is. If your z-score is 0, then you're right at the mean. Okay, you're very typical. If your z-score is greater than 2 in absolute value, so in other words, bigger than 2 or smaller than -2, then we call it an outlier. If the z-score is greater than 3 or less than -3, we call it an extreme outlier. It's very unlikely to happen. Any questions on kind of reading data here? Okay, I have some examples. Okay, so here's an example. Let's suppose, so it's an outlier if the z-score is greater than 2 or less than -2. Because that means it's unusual. Okay. So suppose my goal is to have the most students pass 70% or higher. That's what I'd like in my class. I want most of you to pass the class. Sound good? My guess is you want to pass the class too. Okay. If the average score is 74%, am I satisfied? What do you think? Put in the chat box. What do you think? Am I satisfied? Okay, it's a trick question. The answer is you don't know. Because if all you're told is the average, which is the mean, and you're not told the standard deviation, we don't have enough information to know whether most of the people passed. So now I'm going to give you some more information. Let's say the standard deviation is 0.02%. Okay, and the mean again, or the average was 70%. I mean, was 74%. Am I satisfied? What do you think? If the standard deviation again was 0.02%. Am I satisfied? Okay. The answer is yes, because if you go down 2 standard deviations from 74%, you'll get 73.96%. That's still a passing grade. Even if you're at an outlier below that, if you're just at that range, even if you're at 3 standard deviations below, which means extremely below, you still pass the class. Do you see? So almost just about everyone passed the class. Yeah, they all got C's, but I'm okay with that. I just wanted to pass. Do you see? I know you want A's. So without knowing the standard deviation, you can't know the answer. But with knowing the standard deviation, you can. Because you can look at the z-score of 70, and the z-score of 70 would be 74 minus 70 divided by 0.02, which is 4 over 0.02, which is 200. And that, by the way, never happens. 200 standard deviations below is like, doesn't happen. Even if there were a billion things, it just doesn't happen. Just let you know that. Okay, 3 standard deviations is really rare. Any questions on that idea? Okay, let's do a nursing example. I'll do, my brother's a doctor, and he does the fun thing. What's the one fun thing that happens at a hospital? And I think you'll all agree. It's not fun for everyone, but most everyone. Or a happy thing, at least. He delivers babies. So he delivers babies. So if you're a mom, you know, you're really happy your child was born, probably, right? Okay, so let's suppose that the baby is born Okay, so my brother's delivered a baby, and the z-score in weight for that baby was negative 3.1. What can you say? What do you think? What do you think is going to happen? If the z-score is negative 3.1, and again, it's the variable is weight, the weight when they're born. Okay, I don't see y'all jumping in. Okay, the idea if the z-score is negative 3.1, it's an extreme outlier on the small side. Do you see that? Because it's lower than negative 3. If a baby is born as extremely low birth weight, that baby is going to go to ICU. And there's all kinds of problems that could happen because the baby's too small. If you don't know that, I apologize, but that's true. Okay, does that make sense? What if the baby's weight was 2.7? Then what do you think? Any thoughts? Yeah, the z-score was 2.7. Any thoughts on what might happen? Yeah, now it's an outlier on the high side. So now, if any of you have had babies, you might know this. No, now it's a high because it's positive 2.7. So it's on the high outlier side. It's positive. Okay, that means it's a really big baby. So there's a good chance they did a C-section. Because it hurts to pop out a huge baby. Okay. Of course, I would know because I'm a guy. But if any of you are moms, you know about that. Okay. So then there might be a C-section so that you don't cause like damage when it gets popped out, kind of thing. So that could happen. Okay. If the z-score was, let's say, negative 0.3, then what can you say? Yeah, it's healthy, very close to average, slightly smaller, but not much smaller. And I mean, you hope it's healthy. Other things could happen that have nothing to do with weight, but weight-wise, it's very normal. Does that make sense? So the z-score, even if you know nothing about birth weights, if you're told the z-score, you actually know a lot. Does that make sense? So z-score is a nice indicator of how extreme, large, or small it is, how unusual it is. Any questions on that? Okay, let me give you what's called the empirical rule. And this says that if the shape of the distribution is normal, normal means bell shape. So watch my hand, it goes up and then down. Okay, so maybe I'll make something that looks more normal. So if I pop in, make some of these 90s, these to become 70s. Let me get there, sorry. Oh, shoot, I missed. It's a little closer. It's hard to get a normal distribution just by typing numbers. But notice now it's unimodal, and then it goes down on both sides. That's a little closer to normal. It's not perfectly bell-shaped, but it's not that far. So that's going to be the shape we want. And it's going to be a few weeks before we understand why. But that's the shape that's important. And that'll come up later in this class, and you'll understand another day, I promise. So if you have a normal kind of a bell-shaped curve, then 68% is within one standard deviation of the mean, or has a z-score less than 1, greater than -1. 95% chance of being within 2 standard deviations of the mean. So that's going to have a z-score between -2 and 2. 99.7% chance of being within 3 standard deviations of the mean. Any questions on that? Okay, and that's called the empirical rule. Okay, I'm going to let you read the book and see more details on that because we're kind of running out of time. And sorry that my electricity went out. It sucks. And then there's the empirical rule, but you can only use this when it's approximately normal. So if it's skewed left or skewed right, don't use the empirical rule. Okay, and these are approximates. There's also something called Chebyshev theorem. I'm going to let you read on that. Okay, I've actually done all of this. And here is the secret word. The secret word is stratified. I always try and give you a secret word that has something to do with what we're talking during the time. And I told you stratified sampling is a very important sampling technique. So that's why I chose stratified for the secret word. Just a note, next week's webinar will be Tuesday at noon. So next week is the same as this week. It turns out that Monday, it's an off day for me. So it's going to be Tuesday and then it'll be Monday the next week. But so we kind of go back and forth. And this week we had both, so I had to choose one for next week. So it'll be Tuesday at noon. Just some notes. This symbol with an X with a bar on top, we call it X bar. Easy to remember. And that's the sample mean. Mu is the population mean. S, which we haven't used that letter before, is a sample standard deviation. And sigma is the population standard deviation. So those letters are really important. For typing, just let you know, X bar is very hard to type, even in Canvas with the math toolbar thing. So I will always accept if you write XBAR, okay? So when I grade, I will accept XBAR, no problem. I'll also accept MU if you want to do mu. And I'll also accept SIGMA for sigma. Okay. Turns out this letter and this letter are not that hard to draw. For your projects, you should, because that'll help you with. But for like exams and stuff, you're welcome to use just the letter, the words. And just a quick little reminder, because this is week 1, Thursday, you have your 2 discussion posts. There's the secret word, there's the 2 truths, 1 untruth. And there's also the, it's a week 1 webinar. And just want to show you something because it's important. If I go to discussion, so let's go to modules. That's how you're going to see it. If I go to modules and you go to week 1 and you go to the week 1 survey design, that's going to be one of your assignments. That's a discussion post assignment. What I always do is I put in a model post. And all but the 2 truths, 1 untruth, which isn't supposed to be hard. You don't need help on that. But I always put in a model reply also. But I do want to let you know, never reply to your own post, reply to someone else's post. So just because I replied to my own doesn't mean you should. So I only reply to my own so that you can see what a good post looks like. Does that make sense? And just a note, when you do post, if you have a link, after you copy and paste the link in, either hit the space bar or the enter, and that'll make it linkable so that other people can just click on it. It just makes it easier for other people as a Canvas thing. Okay. So that's just something to note. Those are due Thursday. And then by Sunday, but don't wait till last minute on Sunday, you have to reply to the 2 posts. You also have to do your chapter 1 and chapter 2 assignments. Those are important. By the end of the week, you should have partners for your project. And that you can do using the discussion board for the project. I see some of you have already done that. So there's a lot of assignments, and you have your secret word quiz for week 1, and you have your secret word quiz for the orientation. Okay, and those are quick. Once you watch the orientation, that takes a minute to do that. Okay, so and this week 1, true, and for this one, I recommend answer a lot, make guesses on lots of people. Make a guess on mine too, see if you can guess mine. Okay, so all discussion posts are always due for the initial post on Thursday. And then the reply is due on Sunday, but there's but if you wait till the last minute, sometimes you're not gonna have good ones to reply to. So I don't recommend waiting late, especially on the survey design, because you may not find one that's any good. If you do it a little earlier, you'll find good ones. That's just a suggestion. All right, I think I'm gonna call it. And let's see if it lets me. Like I said, I've never had this happen where the electricity in the college went out and I lost it. Oh yeah, it's still recording. Wonder what it did while I was off. I'm gonna stop recording. Wonder if it paused it. So I'm gonna stop the recording.